Okay, so our third example, and this one dealing with logarithmic functions, is the sound pressure example. And this says that the sound pressure level of a sound is described by the function L of P is equal to 20 times the log base 10 of 50,000 times P, where L of P denotes the sound pressure level measured in decibels, and of a sound having a pressure P measured in pascals. This one actually is where a lot of examples we have are just a specific situation. This is actually a conversion that's used all the time. This is true for anything that happens in air. Generally, we use these values of the constants to figure out how do you convert the pressure of a sound into a decibel level, which is just a different way of keeping up with sounds. And so the other way to think about is to recognize with this is, since it's a log base 10, that every time you're going up one level in decibel, you're going up 10 times that amount of pressure. So that's a significant amount. So, okay, so let's use this equation here. Questions that ask, again, first, almost always asks us to recognize which one is independent, which one is dependent. So, independent is the one inside parentheses P, which is pressure. It's in pascals. The dependent variable L, and I'm going to use the script L to so I don't confuse it with my ones, even though when I print I'll use just a regular L. The L, which is measured in decibels. All right, and so question 1 says, what is the sound pressure? So what is L if the sound has a pressure of 0.500 pascals? Okay, so that's easy enough. We've got P. We want to find L of P. So L of 0.500 is going to equal 20 times the log base 10. And that's kind of redundant in the general way of speaking. We put it on here to make sure, since we're talking about other logarithmic functions in this case, and we've talked about log base E and that sort of thing. In general, if you just see log, would generally mean that to be log base 10, if we're just talking about in computational questions. And so that will solve our answer there. Okay, so what do I need to do here? Is I can just basically punch that in my calculator. I put the variable there. What this should be is times my 0.500, because I know what P is now. And so I know that this is equal to 20 times the log. I'm going to ignore the base 10, as we just said, of 25,000. Okay, so how do I put this in my calculator? So that's a little bit tricky. Some of you may have log buttons directly on the face of your calculator. Mine, at least, I don't see it. I could try to do it with a natural log and do some conversions and stuff like that. That would be much more difficult. I'm going to just find that function in here. So I'm going to start with 20 times, and now I need the log function. And since I don't see it on the screen, I'm just going to go to my catalog and start scrolling down. And so I guess I must have used an E function in there recently. If I use a second function, I can go page by page. Still in the F's, the I's. Now I'm getting the L's, local. There we go. So there's log. And you saw right below it was a log base. So there is a function here that would allow me to put in if I want to do log base 3 or something like that, but we discussed that's usually not something we commonly do. So in this case, I'll take log base 10, or just log of 2,500, and I get that L of 0.500 is 87.96, and the units on L are dB, decibels. Again, if I wanted to break it down into by doing parts, if I just wanted to take the log, easiest thing to do is I already have it up there. But if you were just trying to break out the parts, this is 20 times. I would again have to go to catalog. Fortunately, I just searched for it, so log comes right up. So log of 25,000 is 4.398. And then I can multiply it by 20 and get back to that. There. All right, so that's how we get that one. Part C is what sound pressure will result in what pressure, so what P results from an L of being 110.0 decibels. Okay, so again, as we could have expected from this, we're going to have to set it backwards. That we know that 110 is going to equal 20 times log of 50,000 times P. So divide both sides by 20. I get that 5.5 is going to be log of 50,000 times P. Now, how do I get rid of a logarithmic function? Well, the way I get rid of a logarithmic function is by putting its base to that power. So this is log, remember this is log base 10. So that means 10 raised to the 5.5 must equal 50,000 P. So then P just must be whatever 10 to the 5.5 divided by 50,000 is. And so I can punch that in my calculator real quick. 10 raised to the 5.5. A lot easier to find them doing log. Divided by 50,000. So I get that P equals 6.32 units. It's a pressure, so I know the units were Pascal for that. And again, just as an aside, if you wanted to break it down by parts, if I wanted to do 10 to the 5.5, I would get 316,228 divided by 50,000, which got me back to there. So that's all I need for that one.